Hi guys, and thank you for joining our call today. Maxim, just start, I think.
Yes, this is continuation of the last call where I was giving a demo of the descriptor-based wallet, which we developed at LNPBP Association. This descriptor-based wallet is both the library that can be used by third-party wallet developers. And the main difference of this library from many other libraries that exist out there is basically here. The slide summarizing it is basically that it allows not just work with such things as a Taproot mini script, but it also allows to do very much advanced stuff related to tweaks, which is important for applications related to RGB. The other thing is that this library allows the complete resolution of private keys, which is also a good architectural practice, and it allows to do that to a degree which is not possible with any other wallet. But in practice, we will be using and already using this descriptor wallet library as a part of LNP Node and Rgb Node. The last week, actually, I was working on the integration of the descriptor library into LNP Node. After the demo, I will tell more about how all these components will be interoperating together, the descriptor-based cold and hot wallets, not including just wallets which we are doing, but any other wallet that can be developed with the descriptor wallet library, and how they will interoperate with the Lightning Network, Rgb Node, and normal Bitcoin network. The scheme that wasn't done previously. You know maybe that even getting LNP Lightning Network and normal Bitcoin node working together is already quite a challenge. Adding RGB to that creation and making sure that you always separate the private keys is doubling that challenge. So I will be showing how it can be done. And basically, the descriptor wallet library is created to address specifically these challenges. And to see how it actually works, we created a small two command line tools to work with the descriptor-based wallets. Basically, these are two command line tools as a part of this library. They are not fully fledged wallets. Basically, they do not persist a lot of information, and it's just the professional tools which may be used by some hackers to create advanced Bitcoin transactions. So I will continue the demo from last time, and you remember that we have cloned the GitHub repository into repo structure. The GitHub repository was called Descriptor Wallet, and now in the Descriptor Wallet library, I have the source code or the Rust source code of the library. If we will list it, we will see that there is a lot of files. We can use the Midnight Commander to see the structure of these files. And the library consists of several modules, including modules to work with descriptors, hardened derivation of wallets, on-chain operations, partially signed Bitcoin transactions, script-related functions, and overall library integrating all of this together. If we will go to the documentation website, let me open. We can go to docs.rs, search for, what's with my internet connection? Do you hear me well? Oh, yeah. Search for this library, and you will get quite an extensive documentation about how it can work. You will see that there are different modules, HD, scripts, Pspt, and you can read about the specific components of these modules, or how, for instance, the work with the different forms of Bitcoin scripts is done, and what functions are available for partially signed Bitcoin transactions, including some support for proprietary keys, which we are using in RGB, and so on and so forth. So coming back to the demo. You download and clone it from GitHub. It was on the previous demo. I wouldn't be repeating these comments again. Basically, just git clone https github.com lnp-bp, which is our organization for most of the repositories, and Descriptor wallet, which is the name of repository. So it will create this directory, which I already have. And after that, you need to do what you need to do. Now I will git pull the latest changes from the GitHub. And after that, I can do cargo install path from this directory and using all features. This is the command, and I already published the instructions how you can replicate the demo as a part of the README on the GitHub. Here to yes. So we will wait for a moment while it will compile from the source code. And while it does the download and compilation, I will again go to the GitHub and show that the README has the instruction for this process. Please make sure that you use a proper Rust version. This library works already with the Rust table and even before that. And here is basically the command that I'm currently executing. The compilation is not that long. You see that it compiles different components like Miniscript, Electrum, main Bitcoin library, Lightning related stuff as well. So it includes the support for all of these things. And also different client-side validation parts. And finally, we will end up with the two command lines, commands called BTC cold and BTC hot. It's basically the cold and hot wallet separated, and the hot wallet organized in a way that it can be used on an air-gapped device. So we can test this BTC hot wallet, yes, and we see a number of instructions for it, and BTC cold. On the last demo, on the previous demo, we have already created a seed phrase, a master public key, an account using BTC hot wallet. We created an account-based descriptor for the cold wallet. So if I will look into BTC cold command, I can read some info by inspecting the wallet file. This wallet file is located in this wallet directory from the last call, and it was a WPK SegWit wallet. WPK wallet. If I will inspect it, oh yeah, it has created PSBT file. So let's recreate the wallet. BTC hot. Derive. We will use inspect command actually inspects the PSBT file. So we don't need to recreate the wallet. We just need to check the wallet balance. And we can do that with a check command and specifying this wallet file once again. So we see that the wallet descriptor is this one based on WPK hash, and that the wallet still has some real mainnet bitcoins, which were paid during the last call, and nobody stolen them yet because we had extended public key appearing, seed phrase appearing on the screen, but nobody copied it, hopefully. And finally, we can reuse the same output to complete our demo. So we have this UTXO, which is transaction ID and output number, containing 37,000 Satoshis. This is the address that actually contains this output. And we can go to blockstream.info to see that this is a real transaction in the blockchain. So we see it that it was created not outside of the Descriptor wallet, and this actually the address paid this 37,000 satoshis. Now we would like to spend them, and to spend them we need to create a partially signed Bitcoin transaction with a construct command. And construct command takes a number of arguments. You can always check what are these arguments by typing help in the command line. So it takes a wallet file. It requires you to provide it with a Psbt file. It will save the newly constructed Psbt, and also you have to specify fee. Additionally to that, you have to provide a set of inputs and a set of outputs you would like to create manually. It will add a change outputs automatically if the difference between the inputs and outputs will be plus fee will be more than 0. You can also change the index of the change output. You can specify Electrum server you would like to use, and so on and so forth. You can also provide the custom lock time. The most important part is basically how you specify input. This is done with the input descriptors, which allow you to provide the information of the specific UTXO you would like to spend. You need also to give a hint about derivation path that was used to create the address of that UTXO. You can see this derivation path when you do a check on the balances. This is the derivation path. It's basically the first key that we use. Then you can optionally provide information about replace by fee, including sequence number. You can use a relative log time with either heat or time variant, saying after or older. And you can provide a custom seek hash type. So basically you can create arbitrarily complex inputs with just a command line. And output is simply address and the amount you would like to put on that address, amount of satoshis. Where we are going to spend that? Well, we are going to spend that satoshis for a Taproot output. And to do that, we need to check our Taproot wallet, which we also created last time, and see the address that we can use. All addresses here are empty. This is the output descriptor for Taproot wallet, and let's generate some address. So we have the Taproot address we will be paying to. Now all information is present, and let's do the actual construction. So we will use input for the transaction, which will be our UTXO we found here. We also need to provide the derivation path, which is basic 0 derivation path. We would like to have it being replaced by fee, and we would like to use a complex seek hash all plus seek hash anyone can pay combination, which is, for instance, can be used in coin join payments. Next, we need to say something about the output, and the actual output we will be paying to will be the Taproot address with how many Bitcoins we would like to pay there. Well, probably not all of them. So we will start with paying 7,000, let's say, 7,000 Bitcoins. The rest will be allocated to a change address. Now we need to specify the wallet file, Psbt file, and fee. The wallet file we are paying from will be the PKH wallet, which contains the descriptor to generate all necessary public information. And we will save this into PKH Psbt file locally. Psbt file locally. And the fee we would like to pay, let's say, it's a total fee for the whole transaction, let's say 700 satoshis. Seems like that we have done everything. And by executing the command, the wallet has checked once again, rechecked on the mainnet that this output is actually indeed unspent yet. And it had created Psbt, which was saved into the file locally. So we can see it, Psbt, vpk hash, Psbt, yes, binary file. This is unsigned partially. This is unsigned file. If we will do an inspection with the BTC cold wallet, we will see a lot of information about its structure. We will see that it indeed spends that output you would like to spend. It has that output as its input. It creates two outputs, the 7,000, which we are paying to Taproot address, and the change output. It provides all the information for creating signatures for hardware wallets if they will be used. And it also provides a proper SIG hash type and allows RBF. We will check into the sequence number. We will see that it basically opts in for RBF and many other things. It's not filling in Taproot path because we are not yet spending Taproot output. Anyway, let's sign this Psbt. And the signature should be created with a hot wallet. Again, you can just copy this string or represent as a QR code or print it and transfer to an air-gapped device. So you don't necessarily have to keep the hot wallet on the same device as the cold wallet. And the signature is done with a very simple command, which is sign, and the provided Psbt file. We also need to provide an account which we will use to do the signature, which corresponds to the descriptor wallet, cold wallet that we generated. So this is the account with extended private key. And we have done one signature for that Psbt file. If we will look again the inspection of the Psbt, we will see that additional to all the information, we got a partial signature here that should allow us to spend that output. So let's spend it and finally publish the Psbt. The signature creating command from the hot wallet doesn't do anything else than just creating signatures. It creates signatures for all private key it knows. And you can use multiple hot wallets such that if you have a multi-sig setup between many devices, you can transfer Psbt, adding more and more signatures across participants or across devices. And when the Psbt has signed by or has been signed by all participants, then you finally can finalize it and publish to the Bitcoin network. So again, for that we are using cold wallet, which will not touch the private keys and just work with the already signed Psbt transaction. It is done with a finalize command. If we will check the instructions, we will see that we can specify to which network publish the transaction, customize Electrum servers or server we will use for publishing, and also allow to save the final transaction into a specific file. So we will be published to the Bitcoin main network, and the file is vpk hash Psbt. And we see that transaction has been published. If we will look to this transaction ID, this is the actual context of the transaction, we should be able to see that it is unconfirmed, but it indeed got into Bitcoin main mempool, and it pays to this Taproot address. I will increase the font size here. It pays to this Taproot address, which is XSD86VJ8. And this is exactly the same address that we used for constructing. Here it is, XSD84VJ8. And it pays 7,000 Satoshis. So if we will look into details, it's all here. So that's a good news. Let's wait for mining this transaction. Before doing that, we will recheck the balance of our Taproot wallet we are paying to. As you saw previously, there were nothing on the Taproot wallet. This Taproot wallet is descriptor of Taproot, starting with the Taproot, and nothing was there. So let's do this check once again. Check Taproot wallet, and it already sees the transaction from the mempool. If we will check our previous wallet, we will see that now it has the change address, different address. The remaining part of Bitcoins got to its change address. So I think nothing prevents us from spending the Bitcoins from Taproot address to another Taproot address, which may be, of course, one of our address, but maybe it will be more interesting if some of the participants of today's call will give their Taproot address. Does anybody has already a Taproot enabled wallet to receive the 7,000 Satoshis?
I'm not sure if people are not that greedy or simply not ready yet for Taproot with their wallets.
Let's ask in Bitcoin, in RGB Telegram chat. I'm quite sure that there is a lot of people, and maybe occasionally somebody already have a Taproot enabled wallet.
Okay, I'm asking.
I don't have a Taproot wallet, Maxim. That's why I haven't answered.
Okay.
Moon Wallet have a Taproot support. You have to activate it on settings.
Well, we can do an interesting thing. We can look for Taproot transactions and addresses and just pay to somebody who already made a Taproot transaction in the past, but probably it wouldn't be that interesting. And I don't know how to actually look for a Taproot enabled address using Blockstream Explorer. So let's wait for several moments for doing that. And meanwhile, I will start constructing the Pspt while we are waiting. So again, BTC code, construct, input will be this one, which is basically the transaction output from our address. And we will again use RBF. Oh, first we need to use a proper index, which this time is, oh, sorry, it's not that, it's the, not Taproot address. It was the change address. This is Taproot address. Yes, this is BCP. And derivation path here is again the same, RBF. Probably nothing more fancy stuff to add. And then output, which we are looking for, and I will be paying not 7,000 but 600, 6,500 or 400 to get a sufficient fee. Yeah.
I actually have 2 people right now. Can we make it? Can we split it into 2 addresses? No.
Yeah, no problem.
Okay.
So I will pay 3,000 each, and then we will have even some change to see the change address. So the first address is where to look.
Yeah, I'm dropping it. Just 1 second.
And we have a question, what was the last call bug? Oh, it was really funny thing. It was one of the changes I introduced into the code base half an hour before the presentation, which was just occasionally did not equation check, but non-equal. And it was treating all the transactions as a taproot. So that's why it wasn't able to support to sign the pre-Taproot SegWit transaction, saying that it's incorrect Taproot transaction, which was, of course, indeed the fact. So it took just one character to fix that bug and several minutes. Okay, we have the first output. Oh no, says it's not part of the address. Something incorrect, and we will spend 3,000 there. Let's do it like this, an equal amount. And the second output will be.
Yeah, just 1 sec.
Of course, we can do more interesting stuff, like adding to the transaction 2 inputs, one from 2 different wallets, and then using 2 different hot wallets to add 1 signature per output, and so on and so forth. But I wouldn't be going into that right now, otherwise it will be quite a lengthy story with the command line, because basically it's not about user experience here. For user experience, we will do fancy UI wallet called MyCitadel, which basically will use all this stuff from Descriptor wallet library. And we'll have a mobile application and desktop application. But this is more just to showcase how all the guts and internals are working in there. So are we up with the second address?
Yeah, I'm waiting.
Or you can give yours. Oh no, you don't have. You paid from SegWit. Actually, this wallet also supports Taproot script-based spendings. It's quite complicated to construct them from command line, but again, you can do this stuff as well. Shall we proceed with the?
Yeah, give me a couple of more seconds.
Okay, I will leave output empty. The next thing that we need to specify was a wallet file, and the wallet is Taproot wallet. And the next thing is actually where to sign the transaction, tr/pspt, and then the fee. So for the fee, we will pay. How much did we pay it last time? We paid
700 for the
700. Yes, and round payment amount. Yeah, that was fine. So let's pay another 700 for the fee. And finally, so we have 7,000. We are paying 3,000 to one output, 700 as a fee. So probably we will pay to the another output, well, about 2,000 to have some change as well to be used later. Or shall we proceed just with one output?
Yeah, I think let's proceed with the one.
And we can do more later.
Mm-hmm.
It seems like that we are good to go. Yeah, we already got a PSBT file, and if we will inspect this PSBT, VDC called inspect tr PSBT, we will see that actually it's quite different to SegWit. First of all, because we are getting the full information about previous transaction, which is required for Taproot previously spent transaction. And we also getting the tab key origins field filled in with the derivation path for export only public keys. And that should be sufficient to do the actual signing. So let's sign it. BDC hot sign tr Psbt using our TR wallet. And it haven't worked. I don't know why. Didn't found a key probably to sign. So we're spending Taproot output. Taproot output T4 add 00 to a Taproot to other Taproot output with the TR wallet. And the key comes from 56CF17FA. Let's check the wallet, BTC code, check, wallet TR. We have 56CF17FA, which is exactly the same as public key. The derivation path is correct. Extended public key is correct. Everything should be working fine. So from what I see, it should add signature. Previous output sequence. Interesting. Previous output. Inspecting all the details which can go wrong. Seek hash all. Okay, probably again as usual. Something makes this thing unhappy. BTC full sign. Let's try with a different one. It doesn't find that the key. BTC hot.
Maxim,
Sorry? Yeah.
Zcash hash flag missing, maybe?
Well, by default, it's seek hash all, so it should be working well. I just need to inspect get the info about the wallet just to check that the Taproot wallet is the correct one. So we have the same Taproot descriptor, yes. From what I see, X public key is the 6DF, this one, and here we have this X public key as well. So that is all correct. That is all correct. Let me try once again with, as you said, trying adding seek hash just in case. True that it will be the same. Yeah, it is. Well, it's not working as expected. I was doing the Taproot transaction previously with this command line wallet, so probably it's just something that is, again, I changed in the code, which I have to debug. If you give me one moment, I will be able to find that
Maxim,
transaction. Yeah.
Do you see it's okay the fingerprint is different that you see in account fingerprint and recommended wallet descriptor?
Well, where is it different? This is recommended wallet descriptor fingerprint 56CF17FA. It is the same here. When I construct the transaction and when I inspect the transaction, I also see 56CF17FA, which is the same fingerprint. Which one do you see differently? Like, it seems that it should be all the same.
That fingerprint and in account fingerprint F87 75D43 shouldn't be the same that at the end of the descriptor?
7.5, where do you see it?
In right above where you say see account fingerprint, that one.
This one. Oh no, it's a master. This is fingerprint for the account key. So this is fingerprint for the master public key, master public key, yes. And this is fingerprint for this full derivation path, exactly of this public key. So it specifies the derivation path out of the seed phrase to this specific extended public key, which is account level public key. And if we will see it here, also this fingerprint goes as a seed phrase, and here we use the full extended public key information. So it's just in Pspt, we are having the details about where this extended public key is coming from, which is a required information for the hardware wallet to do the signatures. But the key should be a proper one. If we will look into the inputs, we will see that Taproot key origin. This is the key that we will be using. This is the fingerprint where we should derive it from, and this is a wrong one. Yes, this is a wrong fingerprint, F87. So it basically takes the fingerprint from the master. No, this is correct. F87. Yeah, it is correct. 43. Yes, that is also correct. So it's not the master fingerprint, it's the account level fingerprint, which also corrects. And it uses 0,0 derivation to get that key, which should be used to sign the input. To sign that input corresponding to that address. And the script pub key we are spending previous output. Let's see. 3B0B, 3B0B, which should be a tweaked version of this public key with its own hash. Yes, so it all seems to be correct. This is internal key. This is origin. That's all seems to be correct. So something is going wrong with all of that. And I think that there is some tiny, small, another bug that I've inserted into the code. So I will need more time for debugging that Taproot transaction, but at least we were able to spend the SegWit one, which is also really good. And we will continue with that on the next call. And today I will probably go on with the rest of the presentation that I have for today.
Well, Maxim, I can actually offer, I mean, you told me that you fixed the last bug over like 3 minutes or so.
Yeah.
Would it actually make sense maybe to try to do it now?
Well, I have no idea where the bug is because basically it's not obvious one. It doesn't add the signature. It's not failing. It's not crashing. You just don't find the correct key. And I need to go with a debugger into step-by-step debugging, which will be quite a long story. Maybe it will be interesting for sure how to debug in memory things. But well, I think we will do that. I will do that offline, and we will come to that back on the next presentation at the beginning. Oh wait. So what was I going to say for the end of this talk is basically the way that we came up with of how the actual Bitcoin wallets, universal Bitcoin wallets, let's say like that, can be structured. And by universal, I mean the Bitcoin wallets which seamlessly integrate on-chain and Lightning part. which also should support Taproot, which should work with RGB, hopefully, and which should also clearly separate the private keys to some hardware devices, air-gapped devices outside of them. And unfortunately, as of today, not even talking about RGB, so even if we will remove RGB out of the story, we will find that still there are wallets which work with the on-chain and Lightning part, but these two parts are mostly different parts, different wallets embedded into a single application. And they are really challenging to integrate, to separate properly private and public keys, and also migrate on Taproot support. With RGB, the story becomes even harder. So the design that we came up with is basically that there is thing which is called cold wallet. And this thing, the main responsibility of this thing is to keep information about the wallet descriptors. This is a slide from the previous week, which I was explaining what wallet descriptor is basically a template to generate specific outputs and addresses out of set of public keys. Why set? Because it could be a multi-sig account. And wallet descriptors were introduced in the Bitcoin core, and they allow actually to work with the different types of SegWit, Taproot, multi-sig, arbitrary complex scripts. And basically the cold wallet works with the wallet descriptors which have no information about the private key. They are completely described by just a script, extended public keys, derivation path, and that's all. And what we did with the wallet descriptors is basically we restructured that in such a way that you can always do a derivation without accessing private keys. It has all the necessary information. And as you have seen, that difference, here is a wallet descriptor. It looks differently from what you will see in most of the wallets, because most of the wallet will give you an extended public key here. And after that, we have a hardened derivation, which can be performed without accessing the private key. And what we did is we actually modified the wallet descriptor standard and allowed to embed that, actually not just allowed, but required to embed the extended public key information at the latest hardened derivation path point. And we call that point an account extended public key. And because the cold wallet always have that extended public key at the latest hardened derivation point, it will be always able to generate all the addresses for that account without ever touching a private key. So that's the first thing that we have done. And the cold wallet works with these descriptors. Of course, additionally to that, cold wallet can cache information and do many different other stuff, which is purely user interface related, but the core functionality of the cold wallet is to keep the track of that the wallet descriptors. Another thing which is very important in this context and which is absolutely absent from the existing wallets is ability to store, for the cold wallet, to store information about tweaks. So whenever we will touch use of RGB or any other client-side validation thing that requires pay-to-contract commitments, without this information, the cold wallet wouldn't be able to spend many of outputs created in contexts related to the RGB, for instance. So it also have to store the tweak information as well, and have to be extended to store the tweak information.
So sorry, what is tweak?
Well, the tweak is basically how you commit to some client-side validated data by adding the hash of this data to the value of the private and public key. And you need to provide a proof, which is original value of the public key. And then you can prove that this, it's kind of how open timestamps work and also how single-use seals work. It's a very long story to go into all the details. We had many presentations, and we have a description of these things as LNPBP standards. If you will go to LNPBP, the first three standards cover that topic in depth. Specifically here is the description how the key are tweaked and all the procedure and why it is required. And this value should be known to the wallet. Basically, this value, the tweak value, is created here by RGB. But it should be get to known to the cold wallet such that the cold wallet later will be able to spend that out. The cold wallet, of course, should work with the blockchain and blockchain index, which can be presented by Bitcoin Core, Electrum server, and in some perspective with a BP node, which will be more efficient, compact, and speed up way of indexing Bitcoin blockchain. It's right now the development of it's on hold because it's lower priority than completing the rest of the story. And the cold wallet will work with RGB components. RGB node, there are two main components. The first one is RGB stash. It holds the client-side validated binary data, what we call a stash, and it uses this Alluvium to validate them, because Alluvium executes scripts provided with these contracts and schema and allows to validate the client-side validated state against those. But this binary data is really unusable for the wallets because it's really hard to make sense of them. And for that reason, we need another layer in RGB node, which is called Rgb Contracts. And the contracts daemon uses RGB schema to add semantic meaning to the state of the contract. And it also uses Alluvium scripts, which are different from the contract level scripts, which allow to put that semantical data into some form of user interface, which can be presented by a wallet to a user. So we have two places where Alluvium is used, and this is consensus, let's say, level thing, and this is user interface level thing. That's why they are separate. And of course, RGB to do a validation have also work with a blockchain index. And cold wallet will read the contract information and use that information to construct new transactions related to RGB smart contracts and combine them with a Bitcoin transaction it creates on the normal on-chain mode. So this is on-chain part. Now, the cold wallet doesn't touch private keys. So whenever it creates a Bitcoin transaction, either with RGB or just pure on-chain transaction, and has to talk to hot wallet. And the way we've done that, everything is structured via partially signed Bitcoin transactions, such that they can be transferred to air-gapped device. And this is standard that is supported by the most of existing hardware wallets. So here we are just in a very compatible and safe area. The only thing that we require to change here is basically we need to add quite a lot of specific fields to Pspt to enable the support of these public key tweaks. And on the next call, we will be talking about the Pspt modifications related to the client-side validation, single-use fields, different information added to different fields. And this also, we would like to spend more time in looking into possible security pitfalls which may come from hardware wallets applying these tweaks, because basically hardware wallets need to be able to parse the information about client-side validation such that they will be able to present user with a proper info how many RGB assets are spent together with these tweaks in some particular transaction. But again, it's not the topic of here, but I'm just covering which parts of the wallet story we need to modify to enable RGB. And the final part, which is a Lightning network, and also the thing that we call Booleafrost, which refactors the Lightning network with the support to Taproot and Schnorr signatures, more complex channel types, and RGB as well. And the wallet actually has to be able to interoperate with the Lightning, and the Lightning have to interoperate with RGB to be able to perform some asset operation inside the Lightning channel. Of course, this will be all part of the Bfrost, but again, we're supporting the legacy Lightning Network as well, which will not work with RGB in native mode. And here we also add the Alluvium virtual machine, because this Alluvium virtual machine will be used by Lightning Node to run a custom channel types. So if the plan that we have, it wouldn't be in the first release version. It will take more time. But the plan that we have is that today we will have a set of Lightning Network channel types, including channel factories with a Bfrost and some other types. But maybe one day somebody will come with a better channel design. And what I would like to have that instead of spending years getting all of the Lightning nodes to add this new support to these new channel types, the developers may just write a single Alluvium program, and the Lightning nodes will be able to use this Alluvium program as an extension and add support to new channel types just with a plugin interface. So that is why we have Alluvium here. So this is the overall schemata. And if we will look into the same thing, but with a different angle, we will see that, yes, we have a cold wallet that stores the descriptors and tweak information. Working with a hot wallet, which may be air-gapped, so it can be not connected online, and the hot wallet stores the private keys. There is RGB node storing the stash and contract state, contract state. LNP node that stores the signatures and state of the Lightning and Bfrost channels. And some in the Bit blockchain indexing node, which can be Bitcoin Core, Electrum, BP node in the future, storing Bitcoin blockchain, mempool data, and index of the transactions, the historical transactions. And they all talk to each other in this way. And the architecture with which we done the RGB node and LNP node is done in such a way that they may be isolated into different servers, talking to each other via network, or they may be put onto the same device as well, talking to each other locally, such that you can have a very different setups when you will have a cold wallet plus RGB on your mobile phone, Lightning node in the cloud, cold wallet on hardware device, and using some Electrum server from the wallet developer, or using Bitcoin Core from your home server. Or you may put these three components on the same device, having hardware wallets and running your Bitcoin Core on your home server, and many, many other possible setups, which provides the required flexibility. And from the wallet developer perspective, this thing actually, we will be releasing LNP node and RGB node as a standalone nodes. Well, unfortunately, with the LNP node, quite reasonable that you wouldn't be able to do anything else than work with a Lightning or Bfrost. It's not on-chain wallet, and so on and so forth. So what we will also do as a commercial company already, as a Pandora core, we will integrate all these components into a single solution, which we call Citadel Runtime. And this Citadel Runtime will be a library that can be integrated into mobile application or desktop-based applications, such that you will have a single RPC interface with some control bus that will allow you to access all of these components, including the storage of the descriptor wallets, RGB data, Lightning operations, transaction indexing, and if we talk about mobile wallet, private keys, which may be kept, in this case, on the device. And this architecture may be distributed across cloud-based facilities or local facilities as well. So that's the thing that we are building in, basing on the Descriptor wallet, which I was presenting today as a first main point. I'm quite happy that we already get it to the pre-release stage where it has support for all the features that we need, well, all the features that exist in Bitcoin today. And another thing that I'm working these days is integration of this Descriptor wallet into LNP node, and it's nearly complete. So I will show you some sequence diagrams. I was working during this completion procedure, such that if you remember our previous LNP node presentations, it was it didn't contain any ability to sign, so it was just producing partially signed Bitcoin transactions for funding channels, which has to be signed separately. Now, with the Descriptor wallet integration, it is able to do all the signatures, talking to this hot wallet, which may be either embedded into LNP Node or kept on a hardware device plugged in into a server, for instance, if it is a server-based setup. So this is a work in progress I was working on last week, and hopefully till the next presentation I will be able to demonstrate this. And from that point, we will be concentrating on Bifrost support in the LNP Node, where we will use the Taproot facilities from Descriptor wallet to enable all the signatures required for Bifrost. And after that, we will move to integration of LNP Node with Rgb Node, which finally will end up with a whole this thing integrated together and Citadel runtime somewhere after the new year. So that's all I was planning to tell you about today. Sorry for, again, not being able to spend the Taproot output. Hopefully next time this also will be fixed and I will be able to demonstrate this thing as well. Do we have any questions? Do we have any time for the questions?
I sent, maybe that's for the future call of ours. I received the second address, so I will save both addresses for the next time. Just up so I have them. I got a question. Does it currently at this stage, does it actually matter what wallet exactly is the like vis-a-vis for this transaction of ours?
Does it matter which wallet does what?
Which wallet exactly is the
what is it? You mean paying to?
Yes.
What's the address we are paying to?
Exactly.
No, it doesn't matter. It's about the address we are paying from, not about the address we are paying to. So because the address we are paying from is controlled by the local wallet, hot wallet I'm managing, so it's not related to the address we are paying to.
Okay.
I had a question, well, quite a few questions, Maxim, if you have time.
Yeah, sure.
Firstly, I'd just like to say this is really impressive work. I've been following you for ages. I don't know how many people are behind this, but it's like just impressive, the amount of work and the coverage across so many things.
Thank you very much.
You showed a diagram which had the RGB node, the LNB node, and the hot wallet, cold wallet. Yep.
This one, yeah.
Where if I'm kind of paraphrasing here because I want to learn what you're doing. So my understanding now is that the way you've created these descriptor wallets, you have a cold wallet that is able to effectively create a proposal to sign something. The hot wallet could be a multi-sig or a set of validators that do a round and they all agree and say, yep, we want to mutate the state. And therefore they all agree to sign. And so they move forward the state, which is what is stored, which is part of RGB. Am I kind of capturing that?
Yes. You're correct.
Okay, so
basically, what you can have here that the single cold wallet may work with the multiple hot wallets in a very different setups. For instance, if you will have an exchange, this may be a multiple signing servers with a different signing policies. The cold wallet may also work with a number of RGB nodes related to different tasks. For instance, you will run the same wallet with the same software, but you will have a different accounts. One account related for your family needs, one for your business needs, and so on. You will have different hot wallets and different multi-sigs for that, and you will have different RGB nodes providing the client-side data such that they will be isolated from each other. So you basically can combine that into a different schemes. We were actually criticized for spending so much time. Well, probably this architecture has taken more than a year to develop, design, and implement, and we've been criticized for spending such a lot of time. But my point was that the way the Bitcoin wallets work today, they are not ready for the real financial world production. So they are not ready to bring use of Bitcoin into business. They're not ready to scale the amount of the forms of operations that you have to cover. And we had that need to find the architecture. We call this microservice architecture. And also all these communications are based on Lightning related networking protocols with end-to-end encryption, which we called Internet 2. So we were looking into getting this architecture up and running in order to get that scalability. Moreover, inside these nodes, in RGB node, we have at least 2 services also working as a microservices talking to each other. In LNP node, we have maybe a cloud of these services because each channel runs its own thread, isolated from the rest of the channels. Each peer connection is its own daemon. And they are talking to each other, like, for instance, this is a diagram of how these different daemons of LNP daemon, like the main daemon, channel daemon, on-chain monitoring daemon, signature creation daemon, and the remote Lightning node you're working with, they are all talking to each other, sending asynchronous messages with this architecture and reacting on them. This is all implemented as state machines. So the fact that I was not going even deeper today because it's very technical, but you can split LNP node on 2 different parts, such that you will still have a non-custodial Lightning when your keys for your Lightning channels are on your mobile wallet. But the part that is always online is on your server. And you can use a push notifications in such a way that your server will continue to route transactions even if your mobile wallet is offline, such that it will be brought up online with a push notification, creating signature, returning it back to the server, and so on. So it's really, as of today, we were not able to find any single use case that can't be covered by this architecture.
No, it's very elegant. It's very elegant. So my other question, because I'm trying to learn about RGB, is you gave a very concrete demonstration today, and actually I learned more about output descriptors and Psbts than from all the research I've been doing. So it was very helpful. But do you have anything that describes in similar way RGB, ALU-VM, and goes into quite a bit of detail on how you design a schema, how you I know there are lots of talks. The problem is looking through videos and indexing them and finding which is the right one.
Yeah,
really
and they
hard.
are on the different level of being outdated.
Yes.
Well, currently no, and I think the moment that it will happen is the moment when we will release RGB, because I'm not able to spend more time on, like I ask everybody not to work on the documentation because the things are changing in some way. So we need to document the version that will be actually released. Like 2 calls ago, we had Peter told and everybody invited to discuss the introduction of signed to contract. We changed quite a lot of things. Probably still not sure that it will. Schema is evolving into more modular and simple format. I think that we will end up having similar things node in a couple of months, and after that we will be able to say that from now on we probably will relaunch and redo the whole technical presentation about RGB. I think there will be at least 5 of them, one after one, where we will summarize the final version of RGB on different levels. But this is still, unfortunately, it's not yet time to do that. It will be time when RGB will be finalized. And probably for now, I wouldn't even advise spending much time working 1-year-old presentations because they're not entirely up to date with what we have in RGB.
Okay. Maybe you could do a follow-up to show what the updates are, and similar to the way you did an interactive demo, just bring us up to speed next time, maybe one of the
Well,
other.
I need to have an RGB node working with all these changes before that to be able to show it. So right now, the version of RGB node, it's not having all the updates that we done through this time. So
No problem.
the focus for now is to finish the lighting part, and the RGB part will be updated when we will be integrating with the lighting and bfrost.
Cool.
And it will be final update to RGB because it was the last thing that was lacking the full ability to work with the Lightning Network. Once it's working with the Lightning Network, we don't have anything more to do with it. It now has the virtual machine, the Lightning Network support, and arbitrary complex smart contracts. So finally, we are getting to that point we were aiming for several years.
We have another question.
I have a question. Descriptor, output descriptor are for describe outputs, maybe one or a set of outputs. But I see input descriptors. What is an input descriptor?
Yes. Well, the input descriptor is a supplementary thing. So you see here, this slide I was presenting it last week, and it shows the things that you shouldn't ever lose in red color. So for instance, if you will lose your CEDA master phrase, you lose your funds. The same thing applies to a wallet descriptor because it is the way you pack different keys into into producing an actual address. And while it's much easier to remember than 12 words, for instance, let's say that you have a company with a complex setup with the Schnorr signatures where you use at least 50 public keys and plus some scripts, complex scripts, time lock scripts, and so on and so forth, but you just don't remember the exact way how you put all that together. And if you will lose a wallet descriptor on this information, even though that you have all of your seeds for 50 keys, well, you will spend a lot of time guessing how they have to be combined and what scripts were also added to them to get a wallet descriptor and get access to your funds. So these wallet descriptors are also a crucial information. And the third crucial information is these tweaks and specific derivation paths, which sometimes can be recovered. So theoretically, if you have your RGB client-side validated data, you can run through them and recover the tweaks, which will take ages and developing some custom software probably. And also, you can scan the blockchain and find out which derivation path was you using, but maybe you use some far-away derivation path. So this information should be also kept. The red part is the information that can be lost and easily recovered because output descriptors were created from wallet descriptors using specific derivation path, terminal, which is called, and applying maybe specific tweak. Tracking account is basically a way how you structure the extended public key before putting it to wallet descriptor, so you can extract it from there or derive from seed master and so on and so forth. And the input descriptor you're asking on is neither, it's not something that can be recovered or should be recovered. It's intermediary ephemeral information that is needed to construct the partially signed Bitcoin transaction, because it basically uses output descriptor of the transaction you're spending, and it combines it with the information of how you would like to structure that spending, which is defined at the moment when you do the spending. Like, do you like this transaction to be replaced by fee or not? Do you like to apply some time locks to this transaction? Do you like to use some custom seed hash type? So this is everything that you add to the output descriptor to get the output spent. And using this information, you generate the witness, you generate the actual transaction input, and finalize your Pspt. not finalized, but create your Pspt, which can be signed after that with a certain key. So this doesn't store, this information of input descriptor is not stored in the wallet. It is provided by users through some user interface, and in this case, the user interface we used is basically a string with a derivation path replaced by seek hash information. You can do it in a different way, or even transparently to a user, but just as a matter of structuring that out, we have developed some recommendations which may be useful to other wallets.
Okay, you can think about those are parameters to work
yes.
with. Okay.
The other thing is that input descriptor can be quite useful for cases where you have time-locked output, relative time-locked output, and you would like to keep the information that that specific output was time-locked. And you may store or send the input descriptor to some other party. But again, this information is completely deducible from the rest of the information, and it's not something that is mission critical as a wallet descriptor, for instance.
Great.
Maxim, can I ask you to drop the link to Bitcoin Explorer that you used to verify the transactions from today?
Well, it's a block stream info. It's
I mean the exact data about the transaction, so that
yeah. To the chat.
Yeah, just to the chat.
Okay, just give me 1 second.
Thank you. We also have 2 more questions. The first one is, for the next dev calls, can we have the material to compile to follow your presentation?
Oh yeah, I can do that, of course. Yes. Well, what would be the best channel to distribute that? Chat or something? I will probably give. Yeah.
Maybe you could just write it on GitHub, and then we could just send the link.
Okay.
There's the for example, there's this discussion part of every repository, almost every repository, maybe somewhere there.
Well,
or a wiki page, something. I mean, on GitHub, full stop.
Okay. Sure.
And then we could just send the link to the chat.
Yeah, hopefully, I think that the next demo may be about the Lightning node, LNP node, working with the LNP node that we had before. It's one of exciting things I forgot you to tell. It was quite isolated from the normal Lightning network, the previous version, because first of all, we hadn't time to do the full interoperability and so on and so forth. But the last week, I was able for the first time to get LNP node connecting to C Lightning node and talking to each other, understanding each other. And this week, I'm completing debugging creation of channels with a C Lightning node. So next Wednesday, we'll probably be demoing how the LNP nodes connects to the C Lightning nodes, opens channels, and do normal Lightning transactions with a pure Bitcoins, not talking about RGB yet, but that will bring LNP node into the same division as C Lightning, LND, and Declare as a full Lightning supporting node. And yes, it will use the same descriptor wallet for doing all the signatures for that operations, and this architecture I was showing before. So I think it's quite a huge step to get another pure Rust node that can be embedded into mobile wallets and used on servers. And yeah, that would be the demo for the next meeting, and then I will send instructions how to download and compile it and follow the demo I'm going to do.
Great. Is the next call going to be next week or the week after? Did we shift the schedule?
Oh, I think it should be next week. Anyway, this presentation may take more than an hour, so we can split it into 2 parts. But anyway, it will be the next week.
But we're still on the bi-weekly schedule, right?
Yes.
Good. Perfect.
Maxim, can I ask what is the state of contract term and all the? I was just reading through the presentations while you were talking. What is the state of contract term and things like that, as far as development is concerned?
The state is concept, so
Okay.
Conceptual state. The contractum is a specific language which we plan to work after RGB release. So as of today, we have a low-level language called ALU assembly, ALU WASM, which is really low level, but at least if you really need, you can use it to create an arbitrary smart contract, which I'm doing by myself. Because if I will do contracting before RGB release, it will take another half a year to postpone it and finalize contractum. So that's why we prioritize everything that is required to get RGB working together with Lightning first.
Okay. Are you, I mean, in order to speed up things, I noticed like in the presentation, you looked at what are the options for ALU VM, including, do we use WASM or the EVM or things like that. So does that mean if we could, are you opposed to leveraging anything that's already out there in order to get it? Because my main concern is like right now it feels like you're working with assembly to it's really beautiful. RGB is really beautiful and so elegant, but in order to deploy something, it feels like it's like hacking in assembly right now. And I'm not being offensive or anything, it's just my impression. I could be wrong.
Yeah,
right?
we did a research about using existing virtual machines. If you're interested, we even gave a presentation with the comparative analysis and all alternatives.
Sure.
It was at the beginning of the summer before we started working on AluVM, because we didn't like the idea to create our own virtual machine at all.
Sure.
The problem is that it appeared like client-side validation is very different from Bitcoin world, blockchain world. And if you recall, the task of creating WASM for blockchain from WASM that is used in the web took several years, and in fact is not fully complete yet. With the EVM, it is impossible to use it because it uses account-based, not UTXO-based model. And simply in quotation marks, to take WASM EVM and get work it with RGB will require much more time than just to do AluVM and complete contractum language.
No, I agree with you on that. I was just thinking, there's another project. I don't know if you've seen it. I'm an Erlang developer, so I like a lot of Elixir and Erlang stuff. Mm-hmm. And there's another project called Eternity, and it's some of the guys.
Yes, of course I know them.
Yeah, so they have this language called Sophia, which is, I don't know if it's possible to take something from there and get there faster, but I don't know if you've looked at it. That's why I was just thinking about it.
I was briefly looking into that, but the problem that, well, first of all, to develop any language for now, we just don't have any capacity. So if there is somebody who are interested in do that and they have resources, they may just,
yes.
Like AluVM is open project. If you will be able to compile into AluVM bytecode from Sophia, that would be great. So why not? From Sophia, from Erlang, from Elixir, from LLVM, it will be nice to have some spin-offs who will be working on these projects, but we just don't have capacity to do that. In terms of the virtual machine, again, it's account-based, and it's just not simply transferable. Not saying about.
Yeah, I know. That's what I've found with UTXOs and account-based, and I mean, there's a whole bunch of interesting privacy stuff you can build around UTXOs, which you lose with account-based stuff, which I really like as well.
Yeah, in this regard, what is really close is Cardano thing with the ELE virtual machine and their language that they developed, Lotus. But again, their virtual machine and everything that they done is not yet complete, and it's so over complexified that when I looked into that, I understood that again it would took more of my time to try to get it integrated than just completing of what we have.
Got it. Got it.
With alluvium, is the main property of alluvium. It's really simple, not in terms of understanding how it works, but in terms how it operates. And it does a complete isolation, and it can't fail. It is register-based, not stack-based, and many other things. And the fact that it is register-based and not stack-based make it much more deterministic. All these virtual machines that you've mentioned, they are all stack-based, and they are much more complex in terms of security analysis. When you have a finite set of registers, plus the rules, how we are avoiding failures on zero division, overflows, integer overflows, and so on and so forth, we have them, you get something really robust. And the only problem with alluvium is that to get high-level languages that will simplify the programming for the developers. But this is a doable thing, and it's much easier to do than trying to fight the problems of instability of stack-based machines and security analysis, where you can't formally think about them, or like in case of Cardano, you can formally prove certain things about them, but the proof is much so harder and requires universities to work on that it's not practically feasible for usual smart contracts.
Got it. Thank you very much.
Yeah, you're welcome.
Speaking of WASM and stuff, there is a different question. So Jose had problems with compiling to WASM in the past versions. The question is there any plan to compile to WASM in the future?
What specific repository wasn't compiled to WASM? Yes, there are plans. We need to support WASM for web-based wallets. Basically, it is clearly that things like nodes, full nodes, wouldn't be able to compile to WASM because they are using zero message queue and networking and many things which wouldn't fit into the web browser, and storage and disk access. But that was one of the reasons why we split the nodes from the core libraries, as we call it, like LNP core library and Rgb core library. And the plan is to have the core libraries fully compilable into WASM, such that they can be, and the whole business logic, in fact, for the smart contract validation and Lightning Network operations is embedded into that, such that you will be able to do a wallet, browser-based wallets with these libraries. Yes, you will have to develop the browser integration and storage by yourself, but at least you don't need to replicate the Lightning or RGB logic, business logic.
Yeah, I mean, I believe he meant the new Descriptor wallet.
This new Descriptor wallet. Frankly speaking, it just recently complete, and I had no time to try to compare to WASM. So if somebody is interested, you can send and share the compilation report. We can address the issues and get it compilable into WASM version. Okay, any more questions?
I have one last question, Maxim.
Yeah, go on.
I mean, if you look at the history of Bitcoin, we have several other attempts like what the guys at Risk and people like that have built to try to introduce something like this out there. My question is, what can we do as a community to help RGB succeed and actually get out there? So like, what are the interesting things we can build so that, there's more visibility and things like that? Because it would be really bad to do all this work and then, it just flounders. Do you know what I mean? Have you got people approaching you? Are there use cases where we could deploy this stuff and, get out there?
There are two parts answering this question. The first one, what can be done before the release and what can be done after the release. Before the release, there is no much can be done, because even if we will attract businesses and people interested in doing something with RGB, they wouldn't be able to do that before the release. And basically it will just create more distraction, trying to explain to everybody how to do something when something can't be yet done before the release. And that's why, like, first of all, that's why we are focusing on this release phase. And for us, release, like, we had a thing that we can call a test release last spring. In May, I was doing a presentation of RGB Node and everything, and wallet, working with RGB, doing transfers. But the test pilot use of it have demonstrated that without the part to transfer the consignments and client-side validated data through the Lightning Network, and without Lightning Network implement part of the story, it will really frustrate people to use it, because it's not usable. It's really hardcore, low-level thing, and the Lightning Network adds a layer of usability and transparency from the user experience. So we decided to get RGB fully working with Lightning, which required also to complete many things in terms of Lightning itself. And that's why we spent another half year just working on this part of the story. So it's not, so I wouldn't say that what we have released in the May is a real release, because without Lightning, RGB can't be really released in a practical sense. So now we are finally completing this Lightning part. And after the release of RGB plus Lightning, that will be a point where, so before that point, the only thing that we need is more Rust developers, more people who are able to contribute into different parts of the ecosystem, into LNP Node, into Bfrost, into reviewing specs, into writing, into testing Descriptor wallet, into compiling with WASM, whatever. We just need a developer and auditor force, not the adopters, because there is nothing to adapt yet. After the release, well, again, probably attracting the interest of business to start investing in integrating RGB into their products will be a proper thing, and also educating people. So, because literally, I wouldn't be able to spend all my time helping business to build something on RGB. I have my own stuff to do. I need to complete a lot of things after the release, like contractual language and other, and our own products. So basically, by completing RGB, I will try to do as technically deep as possible to complete the standards and do the presentation explaining those standards and code, complete the code documentation, which is already quite complete, such that after that, people can start studying that and understanding that by themselves. And yes, it will probably take more time, but I clearly wouldn't be educating other businesses, even if I will be paid for that, because just again, the time is not doesn't scale, and they have to complete other parts. So after the release, the real help might be of not just only evangelizing, but also studying, explaining, writing books, blog posts about that, articles, explaining in simple words after looking into all the documents that we have created before the release.
And that
Sorry for a very long answer.
The release. And the documents that we will create after the release still.
Yeah.
And maybe to add to that, right now, maybe you saw it somewhere, we're looking for a Rust developer. Like I can probably, Maxim can correct me here, but we're looking for highly skilled Rust developer right now, and that could really, really help us.
Yeah, we have a funding for that. What we don't have is the Rust developers.
Yeah, the developer.
Yeah,
So
because
that's
yeah.
If you have any capacity or any network that you can share, or any Rust developers that you know who might be interested, please send them to us. That would really, really help a lot.
Yeah, the only problem is that, again, we can't just take middle or junior level devs, because it will slow down the release, not speed it up. So what we need is somebody who is able, for instance, to continue finalizing LNP Node and do some other parts, reducing the amount of work on my side such that I can do more on the RGB part. But it's really hard to find such people, because it just not requires the deep knowledge of Rust, but also knowledge of Lightning Network and Bitcoin. And all of these people are already working somewhere.
Yeah. It might, I mean, given the fact that they're needed in so many places, maybe a whole, just as a ecosystem thing. Jimmy Song, I remember many years ago, used to run a workshop to train up Bitcoin developers. Maybe we need something that is Rust and Lightning, and trains you up so that you can have much more developers. Like, we almost need to build a school.
Yeah, potentially. But it will not take just 2 weeks. It will take several years of experience, unfortunately. So it's even more complex than that.
No, thank you for that. Thanks.
Bless you. Okay, shall we wrap this call up and look for the next week to complete the demo and have a lightning fun? Done.
Sure. It's been a while. Thank you very much, Maxim, for the presentation, for the demo. We'll save.
Thank you, everyone. We are on the exactly same place where we have stopped the demo. I have done some local debugging, and I found out that it wasn't real bug. It was more specifics of X coordinate only Schnorr public keys, which basically, with the Schnorr BAP, now we have 2 public keys corresponding each secret key. And the wallet, hot wallet, it basically checked that the public key derived from the secret key equals to the public key from the Pspt. But it wasn't the case, because it had a different parity. So for Taproot, we had to skip the parity flag of the key when we do the check. And I fixed that locally. And now I'm ready to continue the crazy part of the demo. So if you remember, the Psbt wasn't signed because of this problem. If we will look into the Psbt itself, let me see this. Inspect. We see that this Psbt lacks partial 6. Just a second. Partial 6. None of them are there, and that was due to the fact that if you see the Taproot key regions and Taproot internal key, this is the public key, and it have a different parity comparing to the key derived from this master key. And that was the actual problem. So now I will do a git pull with a fix. I will get one commitment that fixed that specific problem. If you will see the log, we will see that it's fixing failed Schnorr key parity flag. And now I should compile it. Once again, recompile it. It should be really quick because only one file has changed. It's ready. So here you see that none of the signatures were produced by this command, and I will just repeat it. sign, and we have one signature. Yeah, that was the actual problem, and if we will inspect this Pspt, we will see that the partial signature should appear. No, sorry, not a partial signature. It's a Taproot signature. So we should have it here. Taproot key seek. Wow, that's really cool. And now let's try to publish it. Let's try to publish it with the cold wallet. Publish. Finalize. Publish to the Bitcoin mainnet. And the transaction is tr-pspt. And transaction got published. If we will look into the Blockstream Explorer, unconfirmed. It just got to the mempool. And we see that, where it is? Oh, here it is. It got to mempool, and here it pays to the address that was given before. That exact amount, 2090.87, and it provides the change to another address that this wallet controls. So if we will make a check for the wallet, I will see the change address with this amount of satoshis coming back to me. Woohoo! So I think that's really cool that we got a first Taproot transaction paying to external guy happening.
That was the first address, right?
Yes, that was the first address.
Okay. Can we try to do the same with the second address? No, or it's too.
No, of course we can. We can. Yeah, why not? Why not? So we need to construct another BDC. BDC called construct input. The input is this one. And what is the second address? It uses the derivation from a change. That's why I'm changing the derivation path. Now the output will be
I sent it to the chat.
In just a second. The output will be this one, and we will without this, and we will pay how much? Well, probably we will pay 2,500.
Okay, then we'll like with their address anyway. Let them.
I don't want to create actually the dust addresses. So it will 300 and 200, 500. We will pay for a fee. I think that should be enough, and we will use the Taproot wallet, and we will store the transaction as a TR2 Psbt. So the transaction is created now. Just BDC hot sign this transaction TR2 Psbt with our TR private key. Done one signature. Wow. BDC called publish finalize. Publish to Bitcoin mainnet. TR2 Psbt. Seems like everything. You got the transaction published. This one, yeah, still unconfirmed, and we got the second one.
Woohoo!
Yeah, the second one paying to a single output with a fee. Everything worked correctly, and it is RBF transaction as we specified in the command prompt here. So yes, it just simply works. And if we will ask our wallet to check, it sees that all funds are now spent.
I don't have my 20 francs anymore.
You don't.
Fuck.
So Taproot Descriptor wallet is working.
Yay! Congratulations.
Thank you. Thank you.
Well done, well done.
And on this positive point, we can finalize finally the call today.
Perfect. Thank you, Maxim.
Thank you.
Guys for jumping in on the call again.
Yeah, see you next week. Bye-bye.
See you next week. Bye, dudes.